And now we'll begin learning about graphs and lines. Now notice that a graph of a function f, it's the set of all of the points in the plane that satisfy an equation, like y equals f of x. So these points are all of the ordered pairs, the xy pairs. So when we graph a function like f of x equals 2x squared minus 9, we frequently write it with a y instead of the f of x. Y equals 2x squared minus 9. And we find all of the xy pairs that satisfy this equation, or that will work when we plug it in. Well, let's take x equals 2, for example. Well, in that case, we know that y would equal 2 times 2 squared minus 9, because if that x is replaced with 2, this x must also be replaced with a 2. So let's see. 2 squared is 4. 4 times 2 is 8. 8 minus 9 is negative 1. Okay, so that means that the ordered pair 2, negative 1, that's the x value and that's the y value, is one solution to this equation. All right, well, let's plot a few more points that satisfy this equation, and then we'll use the point plotting method, which means just to draw a nice smooth curve through all of the points. Okay, so let's see. I think we already did one of them. When x is equal to 2, we saw that y was a negative 1. All right, well, let's plug in a 0 first. That looks like it's going to be the easiest of these. If x is a 0, we get 2 times 0 squared minus 9, which is equal to negative 9. So the ordered pair we obtain is, maybe I'll write them over here to the left, 2, negative 1, and this was 0, negative 9. And since we've done these two, let's go all the way to the bottom. If x is equal to 3, y is going to be 2 times 3 squared minus 9. And what does that equal to? 3 squared is 9. 9 times 2 is 18. 18 minus 9 gives us a positive 9. So 3, 9. That's 3 ordered pairs we have. Now let's compute 2 more. Let's do the negative 3. Why will that one be so easy? Well, we already plugged in a 3. And when you take 3 squared, you get the same thing as if you plug in negative 3, because negative 3 squared is also 9. So whether you plug in a 3 or negative 3, you'll get the same value for y. So let's just write 9. Okay, last one would be a negative 1. Well, let's see, y would be 2 times negative 1 squared minus 9. Negative 1 squared is simply 1. 1 times 2 is 2. 2 minus 9 equals negative 7. So negative 1, comma, negative 7. All right, well, we have 5 points to plot. This is the origin right here. So let's start at the top. Negative 3, comma 9. So we go to the left 3, 1, 2, 3, and go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, we took care of that one. Maybe I'll come all the way down to the bottom since we've got some symmetry here. 3, comma 9. We'll go to the right 3 and up 9, which would put us right there. Then we have negative 1, negative 7. Negative 1, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. Down 7, that would be negative 1, negative 7. 0, negative 9. Puts us all the way down to here. And let's see, the last one, the one we didn't do, is 2, negative 1. 2 to the right and down 1. Well, if we were to plug in other points, we would find out that since 2, negative 1, we'd find that negative 2, negative 1 gives us the same height. And we had negative 1, negative 7. Well, positive 1 would also give us a negative 7. So I'm just plugging in additional points. And I know it looks like this would come down, this graph, when we draw a smooth curve, it looks like it comes down to a point. Well, it really doesn't. It actually is smooth down here. And then goes up like that. So that's the graph. Okay. Finally, for this short video, a function is a linear function if it can be written in this form. You probably remember that. Y, or f of x, equals mx plus b. Just some questions to think about. Why is it called a linear function? Well, one simple reason is when you graph it, it's going to be a straight line. With no equation given, how many points must you be given in order to draw a specific line? Well, if I were thinking of a line, and if I gave you 2 points on that line, that's all you would need. You could just connect them with a nice line going straight through them. So you need 2 points.